Elon Musk just did something nobody saw coming. He announced a $15,000 Tesla. Not 30,000, not 20. 15? That's cheaper than most used cars, and it completely changes the electric vehicle game. For years, people complained that Teslas were too expensive for regular families. Now Musk is about to flood American streets with EVs that cost less than a year of college tuition. But here's what makes this even crazier. This isn't just a stripped-down budget car with wheels. Early leaks suggest Tesla packed it with technology that could embarrass vehicles twice the price. So today, I'm walking you through the design choices, the battery breakthrough, the production strategy, why this threatens every automaker on the planet, how Optimus robot fits into the picture, and whether Tesla can actually pull this off. The price war begins. Let's rewind to understand how we got here. In 2024, Tesla faced a problem they had never really dealt with before. BYD, the Chinese electric vehicle giant, was eating their lunch. BYD flooded markets with EVs priced around $12,000. $12,000, Tesla's cheapest model at the time, the Model 3, started at around $40,000. You can see the issue. Musk watched BYD's sales numbers climb month after month. In 2023, BYD sold over 3 million vehicles. Tesla sold about 1.8 million. The gap was widening. Chinese automakers were not just competing, they were winning. And they were doing it by making EVs affordable for normal people, not just tech enthusiasts or wealthy early adopters. Musk realized something crucial. If Tesla wanted to dominate the global EV market, they couldn't just make the best cars. They had to make the cheapest cars. For years, Tesla aimed at the premium market. The Model S was a luxury sedan. The Model X had those fancy Falcon wing doors. Even the Model 3, marketed as affordable, still cost more than most families wanted to spend. That strategy worked when Tesla was the only serious EV maker. But by 2024, the market had changed. Dozens of companies were pumping out electric vehicles. The competition was brutal. Musk needed a new approach. He needed to build a car so cheap that price would no longer be an excuse not to buy electric. Internal discussions at Tesla reportedly got heated. Some executives worried that going too cheap would damage the brand. Tesla had spent years building a premium image. Would a $15,000 car make people think Tesla was cutting corners? Musk didn't care. He saw what was happening in China. He saw BYD's growth. He knew that if Tesla didn't act fast, they would lose the mass market forever. So he made the call. Tesla would build the cheapest EV on the planet. Not just cheap for Tesla, cheap for anyone. The target price was set at $14,999. Industry analysts thought he was bluffing. Automotive experts said it was impossible. The math didn't work. Batteries alone cost more than that in most EVs. How could Tesla possibly build an entire car with all the technology and safety features required for under 15 grand? Musk just smiled and told his team to figure it out. The project got a working name inside the company. Model 2. It wasn't official yet, but everyone knew what it meant. This was Tesla's entry-level vehicle, the people's Tesla, the car that would bring electric vehicles to the masses. And Musk wanted it ready by the end of 2025. Designed to be different. So what does a $15,000 Tesla actually look like? For months, speculation ran wild. Some people expected a tiny bare-bones box on wheels. Others thought Tesla would just shrink the Model 3 and call it a day. Both groups were wrong. Leaks started appearing in late 2024. Blurry photos, sketches from inside Giga Texas, descriptions from people who had seen early prototypes. The picture that emerged was surprising. The Model 2 didn't look like a cheap car. It looked like a concept vehicle from the future. Tesla went with a compact hatchback design, smaller than the Model 3, shorter than the Model Y, but the proportions were completely different from anything Tesla had made before. The front end sat lower. The roofline curved more aggressively. The whole car had this squat, planted stance that made it look fast, even sitting still. Musk personally pushed for a design that would stand out. He didn't want the Model 2 to be a forgettable economy car. He wanted people to look at it and immediately recognize it as a Tesla. But he also wanted it to have its own identity, not just a baby Model 3. Something fresh. The headlights became a focal point. Earlier Tesla models used horizontal light bars that stretched across the front. The Model 2 ditched that. Instead, Tesla designed sharp, angular headlights that sat higher on the front fascia. They looked aggressive, almost angry. Some people compared them to a predator's eyes. The front bumper was almost non-existent. Tesla smoothed everything into one continuous surface. Fewer panels meant fewer parts to assemble. Fewer parts meant lower cost. But it also meant the car looked sleeker, Cleaner, more aerodynamic. Tesla obsessed over aerodynamics because it directly impacted range. Every curve, every angle, every surface was tested in computer simulations thousands of times. The goal was to slice through air with as little resistance as possible. Less drag meant less energy wasted. Less energy wasted meant longer range. Longer range meant they could use a smaller, cheaper battery. The side profile revealed something interesting. No door handles, at least not traditional ones. Tesla went with flush, electronic buttons that you press to open the doors. When the car was locked, the buttons disappeared completely into the body. This wasn't just for looks, it reduced drag. It also cut costs because mechanical door handles have more moving parts that can break. The rear end featured a small spoiler integrated into the hatchback. Not a big wing, just a subtle lip that managed airflow off the back of the car. The tail lights wrapped around the corners, narrow and sleek. Again, no light bar. Tesla was clearly trying to establish a new design language. Some early reactions were mixed. A few longtime fans complained that the Model 2 looked too different. They wanted something that felt more connected to the existing lineup. But most people loved it. Online forums exploded with excitement. Renderings based on the leaks got millions of views. People started placing imaginary reservations before Tesla even confirmed the car existed. The interior photos leaked a few weeks later. That's when things got controversial. The minimalist gamble. Tesla had to make tough choices. You can't build a $15,000 car without cutting something. The question was what? The interior of the Model 2 reflected those decisions clearly. First, the seats. No vegan leather. The Model 2 used fabric. Durable fabric, but fabric nonetheless. It was easier to clean than cloth in older cheap cars, but it definitely felt less premium than what you got in a Model 3. The seats were also not heated. In a Tesla, that was almost sacrilege. Heated seats had become standard even in the base Model 3, but adding heating elements costs money, so they got cut. The seat adjustment was manual. No electric motors to slide the seat forward or recline the backrest. You pulled a lever and pushed the seat where you wanted it. Old school, simple, cheap. The panoramic glass roof, one of Tesla's signature features, was gone. The Model 2 had a regular metal roof with a smaller sunroof option available for extra cost. This saves significant money. Glass roofs are expensive to manufacture and install. They also add weight. A metal roof was lighter and cheaper. Tesla kept the giant center touchscreen. That was non-negotiable. The screen was how you controlled everything. Climate, navigation, media, even adjusting the side mirrors. But the screen in the Model 2 was slightly smaller, 15 inches instead of the 15.4 inches in the Model 3. A tiny difference, but it saved a few dollars per unit. The sound system took a hit. Tesla dropped from 14 speakers in the Model 3 down to 8 in the Model 2. Audiophiles would notice. Regular drivers probably wouldn't care. You could still listen to music and make calls. It just wouldn't sound quite as rich. Ambient lighting was simplified to a single color. Most Teslas let you choose from multiple colors to set the mood. The Model 2 gave you white. That's it. This was pure cost cutting. LED strips that change color require more complex wiring and controllers. Single color strips are dirt cheap. The windows were single pane instead of double pane acoustic glass. This meant more road noise inside the cabin. On the highway, you would hear the wind and tire noise more clearly than in a Model 3. Tesla decided most buyers at this price point would accept that trade-off. No wireless charging pad for phones. You got USB ports. Plug your phone in like it's 2015. Wireless charging pads add cost and generate heat that needs to be managed. Not worth it for a budget model. The climate control was manual instead of automatic. You set the temperature yourself. The car didn't automatically adjust fan speed or air distribution. Again, simpler is cheaper. When these details leaked, the reaction was predictable. Some people were horrified. They couldn't imagine buying a Tesla without heated seats or a glass roof. Others pointed out that even with these cuts, the Model 2 still offered more technology than most gas cars at the same price. The debate raged online for weeks. But here's what most people missed in all the arguing. Tesla was making these interior sacrifices to invest heavily in something far more important: the battery, the aluminum revolution. Tesla had used lithium-ion batteries in every vehicle they ever made, from the original Roadster to the Cybertruck. Lithium had been the foundation of the electric vehicle revolution. But lithium had problems. The price of lithium swung wildly. In 2020, lithium carbonate cost about $6,000 per ton. By 2022, it hit over $80,000 per ton. Then it crashed back down. This volatility made it nearly impossible to predict battery costs years in advance. Tesla hated that uncertainty. Lithium mining also had environmental and political issues. Most lithium came from a handful of countries. China controlled much of the refining. If you wanted to build millions of EVs, relying on a supply chain dominated by one country was risky. For the Model 2, Musk reportedly pushed his battery team to think completely differently. Stop trying to improve lithium batteries. Find something else entirely. The answer they came back with shocked everyone. Aluminum-ion batteries. Most people had never heard of aluminum-ion technology. It had been researched in labs for years but never commercialized. The reason was simple. Early aluminum-ion batteries couldn't match lithium's energy density. They held less power for the same weight. But by 2024, researchers had made breakthroughs. New cathode materials, better electrolyte formulations. Suddenly, aluminum-ion batteries were hitting energy densities of 500 watt-hours per kilogram. Lithium-ion batteries in most EVs delivered around 250 watt-hours per kilogram. Aluminum-ion was double. Let that sink in. Double the energy density meant you could cut the battery size in half and still get the same range, or keep the same battery size and double the range. For a cheap EV, this was game-changing. But energy density wasn't even the best part. Aluminum is the most abundant metal in the Earth's crust. It's everywhere. Mining aluminum is easier and less environmentally damaging than lithium. Refining it is simpler. The supply chain is diversified across dozens of countries. No single nation controls aluminum production. Aluminum-ion batteries also charged faster, much faster. The chemistry allowed for higher charge rates without degrading the battery. Early tests showed a 53 kilowatt-hour aluminum-ion pack could charge from 10% to 80% in under 15 minutes. That's competitive with the fastest lithium batteries on the market. Safety was another advantage. Aluminum-ion batteries were less prone to thermal runaway. In plain English, they were much harder to catch on fire. Lithium batteries, if damaged or overheated, could ignite and burn intensely. Aluminum batteries didn't have the same risk. This meant Tesla could simplify the cooling system and reduce safety buffers, cutting more cost and weight. The price difference was the clincher. Aluminum is cheap. An aluminum-ion battery pack cost about 30% less to manufacture than an equivalent lithium-ion pack. For the Model 2, Tesla estimated they could build a 53 kilowatt-hour aluminum pack for around $3,000. A lithium pack with the same capacity would cost closer to $5,000. That $2,000 savings was the difference between hitting the $15,000 price target and missing it completely. Of course, there were challenges. Aluminum-ion technology was unproven at scale. No one had built millions of these batteries. Tesla would essentially be betting the entire Model 2 program on a technology that had never been mass-produced. If something went wrong, if the batteries degraded faster than expected or had issues Tesla didn't anticipate, the whole project could implode. Musk decided the risk was worth it. He greenlit the aluminum-ion program. Tesla quietly partnered with a materials science company to develop the cathodes. They built a pilot production line at Giga Texas to test manufacturing processes. By mid-2025, Tesla was reportedly producing thousands of aluminum-ion cells per day. Early results were promising. The batteries performed as expected. Range tests showed the Model 2 with its tiny 53 kilowatt-hour pack could travel over 300 miles on a single charge. That was more than enough for daily driving. It beat many EVs with much larger batteries because the Model 2 was so light and aerodynamic. Tesla planned to offer two versions: the standard Model 2 with the 53 kilowatt-hour pack and 300-mile range, and a long-range version with a larger pack pushing the range past 400 miles. The long-range model would cost more, probably around $19,000 or $20,000. Still absurdly cheap for that kind of range. Word of the aluminum-ion battery leaked in early 2025. The reaction in the industry was disbelief. Battery experts questioned whether Tesla had really solved the problems that had plagued aluminum-ion technology for years. Competitors scrambled to investigate. Some companies started their own aluminum-ion research programs, but Tesla had a massive head start. If the aluminum battery worked as promised, it would give Tesla a crushing advantage, not just on price, on range, charging speed, safety, and supply chain security. It was the kind of breakthrough that could define the EV market for the next decade. The factory reinvented. Even with a cheap battery and a simple design, Tesla still faced a massive challenge. How do you actually manufacture a $15,000 car at scale? The answer required rethinking the entire factory. Traditional auto plants assemble cars on a moving line. The vehicle moves from station to station. Workers and robots add parts at each stop. It works, but it's slow. Every station has to finish before the car moves to the next one. If one station has a problem, the whole line stops. Tesla had already optimized this process better than almost anyone. Their factories were fast, but fast wasn't enough for the Model 2. To hit their production targets, Tesla needed to be radically faster. They needed a new manufacturing method. Enter the unboxed process. The idea was brilliantly simple. Instead of assembling the entire car in sequence, build major sections simultaneously. Build the front end in one area. Build the rear end somewhere else. Build the interior cabin in a third location. Then bring all the sections together at the end and connect them. Like building with Lego blocks instead of stacking bricks one by one. This approach had huge advantages. Different teams could work on different sections at the same time. If one section had a problem, it didn't stop work on the others. You could scale production by adding more parallel work areas instead of trying to speed up a single line. Tesla had tested the unboxed method with the Cybertruck. The results were promising but mixed. The Cybertruck's weird angular design actually made unboxed assembly easier in some ways. The Model 2 was more conventional, which created different challenges, but Tesla's manufacturing engineers were confident they could make it work. The Model 2's body structure was key to the whole strategy. Tesla used their Giga casting process to create enormous single-piece sections. The front third of the car was one giant aluminum casting. The rear third was another. This eliminated hundreds of parts that would normally be welded or bolted together. Fewer parts meant fewer things to assemble. Fewer things to assemble meant faster production. Giga casting also improved quality. When you weld dozens of small panels together, you get gaps and misalignments. Cast the whole section as one piece and it's perfectly precise every time. The Model 2's body came out of the Giga press looking almost finished. Tesla had to add very few additional panels. Paint was another area. Tesla optimized aggressively. Traditional auto paint involves multiple layers. Primer, base coat, clear coat. Each layer needs to dry. The whole process takes hours. Tesla developed a new single-layer paint system for the Model 2. One coat, done. It dried faster and used fewer chemicals. The trade-off was fewer color options. The Model 2 launched with only 5 colors: white, black, gray, blue, and red. No fancy metallics, no custom options. Pick one of the 5 or don't buy the car. Assembly of the sections happened fast. The front casting got the motor, suspension, and cooling systems installed. The rear casting got the battery pack and rear motor if you ordered the dual motor version. The cabin got the seats, dashboard, and screen. Then massive robots lifted all 3 sections and joined them together. The whole connection process took about 3 minutes. Tesla claimed they could build a complete Model 2 from start to finish in under 6 hours. Compare that to traditional automakers who need 20 to 30 hours per vehicle. If Tesla hit their production targets, they could make over 4,000 Model 2s per day at a single factory. That's over 1 million cars per year from one plant. Tesla planned to build the Model 2 at Giga Texas initially. Later, they would add production at Giga Berlin and possibly Giga Shanghai. Combined capacity could hit 3 million units per year by 2027. Labor was minimized throughout the process. Robots did almost everything. Humans mainly supervised and handled quality checks. This kept costs down and consistency up. It also meant Tesla didn't need to hire thousands of new workers. Critics raised concerns about job displacement. Building 3 million cars per year with mostly robots meant fewer manufacturing jobs. Tesla's response was that the lower price would create jobs in other areas: sales, service, charging infrastructure, software development. Whether that actually balanced out was debatable. But one thing was clear: Tesla was pushing automation further than any automaker had before. The Model 2 was as much a manufacturing achievement as an engineering one. If it worked, it would rewrite the rules of car production. The robot in the room. While everyone obsessed over the Model 2, Musk was quietly building something that could be even bigger: Optimus, the Tesla bot, a humanoid robot designed to do basically anything a human could do: walk, run, pick things up, manipulate objects. Most people saw Optimus as a side project, a cool tech demo, something that might be useful in 10 or 20 years. That was a huge misunderstanding. Optimus was central to Tesla's entire strategy. Let's connect the dots. Tesla wanted to produce millions of vehicles per year. They were already pushing automation as far as it would go. But there were still tasks that robots couldn't do. Tasks that required human-like dexterity and adaptability. Installing wire harnesses, placing interior trim pieces, inspecting welds, quality control. These jobs required human workers because traditional industrial robots were too rigid and specialized. They could do one task really well but couldn't easily switch to something else. Optimus changed that. Optimus was designed to be general purpose. It had hands that could grip and manipulate objects almost like human hands. It could walk on two legs, navigating spaces built for humans. It had cameras and sensors that let it see and understand its environment. And it ran on Tesla's AI, the same neural networks that powered full self-driving. In late 2024, Tesla started testing Optimus in their factories. Early versions were slow and clumsy. They walked cautiously, they dropped things, but they learned fast. By mid-2025, Optimus Gen 3 was running at almost 7 miles per hour. Its hands had been completely redesigned with a tendon-like cable system that mimicked human finger movement. It could thread a bolt, fold a towel, pick up a fragile glass without breaking it. Tesla's plan was to deploy thousands of Optimus robots in their factories by 2026. These robots would handle the remaining tasks that humans currently did: install parts, run quality checks, move materials, even clean the factory floor. This would push Tesla's labor costs down even further. But the real genius was in the business model. Tesla wasn't just building Optimus for their own factories, they planned to sell it. The target price for a production Optimus was around $20,000 to $30,000. Expensive for a consumer product, but dirt cheap for a business. Compare it to hiring a human worker. Minimum wage in the US is over $15,000 per year. A worker costs way more when you include benefits, training, and management overhead. An Optimus robot would pay for itself in under 2 years. After that, it's basically free labor. The market for humanoid robots was potentially enormous. Every factory in the world, every warehouse, every restaurant and retail store, anywhere humans did repetitive physical tasks, you could replace them with Optimus. Musk estimated the total addressable market was in the trillions of dollars. Optimus Gen 3's recent upgrades showed how serious Tesla was. The running speed improvement meant the robot could cover ground faster in a warehouse or factory. The hand upgrade meant it could handle delicate assembly tasks. These weren't flashy features for demos. They were practical capabilities designed to make the robot useful in real work environments. Tesla planned to start selling Optimus to outside customers in the third quarter of 2025. Initial buyers would likely be large industrial companies willing to beta test the technology. Amazon, Walmart, maybe other automakers. By 2026, Tesla expected to ramp up production significantly. They wanted to build hundreds of thousands of units per year, maybe millions eventually. The implications were staggering. If Optimus succeeded, it would generate more revenue for Tesla than their entire car business. It would also spark a massive societal shift. Millions of jobs would disappear. New jobs would be created, but probably not enough to replace what was lost. Musk acknowledged this publicly. He said some form of universal basic income would probably become necessary. Not everyone agreed with that solution, but almost everyone agreed that humanoid robots would cause major economic disruption. Tesla's advantage in this race was their AI. Most robotics companies were building robots with traditional programming. Tell the robot exactly what to do in every situation. That approach didn't scale. The real world was too complicated. Too many variables. Too many unexpected situations. Tesla's approach was to train the robot with neural networks, show it millions of examples, let it learn patterns, let it generalize. This was the same approach that made full self-driving work. It meant Optimus could adapt to new tasks without being explicitly programmed for each one. By late 2025, videos of Optimus working in Tesla factories started leaking online. The robot moved smoothly. It picked up parts and installed them precisely. It walked between workstations without bumping into things. It looked less like a science experiment and more like a practical tool. The public reaction was mixed. Some people were excited about the technological achievement, others were terrified about job loss, and some just thought it was creepy to watch a humanoid robot moving around. But whether people liked it or not, Optimus was coming, and it would change manufacturing, logistics, and maybe society itself. Now let's bring this back to the Model 2. Because Optimus and the Model 2 were connected in a way most people didn't realize. Tesla planned to use Optimus robots to build the Model 2. The unboxed manufacturing process was designed with Optimus in mind. The work areas were laid out for robots that could walk and use their hands like humans. As Tesla ramped up Model 2 production, they would simultaneously ramp up Optimus deployment. Each generation of Optimus would make the Model 2 cheaper to build.
and the profits from selling the Model 2 would fund more Optimus development. It was a virtuous cycle. Tesla wasn't just trying to win the EV market, they were trying to win the robotics market and the manufacturing market at the same time. The Model 2 was the vehicle. Optimus was the factory worker. Together, they represented Musk's vision for the future of production. Make products so cheap that everyone could afford them, and make them with robots so they kept getting cheaper over time. That was the plan anyway. Whether it would actually work was the $15 trillion question. The answer would start becoming clear in just a few months when the Model 2 finally launched. So there you have it, the full story of Tesla's $15,000 electric car and the robot army that's going to build it. If you found this interesting, hit the like button and subscribe because this is just the beginning of the story. Tesla's about to shake up multiple industries at once and you'll want to follow what happens next. Thanks for watching.